Hello, and welcome to the Johnson Controls Blue Water webinar for February 2023. I am Craig Hanna, and I am grateful to serve as the engineering manager of the Johnson Controls Water Infrastructure Technology team. Our team of subject matter experts is dedicated to designing, installing, and commissioning projects that reduce water loss, that increase water utility staff efficiency, and that decrease operational and maintenance expenditures. Our team exists to provide your water utility with everything it needs to be a top performing organization. You've been asking us to give you more information about static water meters, and today we will be discussing both static and displacement water meters. We have been conducting a research project since late 2010 in which we compare the two different water meter types at typical residences. I know that you will find today's webinar to be filled with surprises. But first, I would like to introduce you to two of my teammates, Audrey Noel and Jonathan Gunn. Audrey, would you please tell us more about yourself and how you help water utilities?
Sure, thanks, Craig. I'm Audrey Noel, Director of the Water Infrastructure Technology team here at Johnson Controls. I have 7 years of industry experience, a Juris Doctorate with an emphasis in environmental law, and decades of experience in operations. I have the privilege of leading the team from the sunny shores of Huntington Beach, but I couldn't do it without our very knowledgeable and talented market manager, Jonathan Gunn, who offices just 2,700 miles northeast of me in Canandaigua, New York. Jonathan, would you please tell us a bit about your experience, please?
Yeah, good morning. Thank you, Audrey. Again, Jonathan Gunn, market manager with the team. I have 13 years in the industry, and like Craig, I serve on a number of different committees, and including as the current chair of the Customer Metering Practices Committee, chair a subcommittee as well, and I also co-author a number of manuals, publications, and articles. So great to be here with you this morning. And we know a number of you have been with us for a few webinars now, and we say thank you for your continued coming back. Apparently we're doing something right, so we appreciate that. For those who may be new, or for those who maybe just haven't been able to hit every one, or there's different reasons going on, I did want to bring up that as of a few weeks ago, we have an official playlist now on the Johnson Controls YouTube channel. And so if you just go to YouTube, search Johnson Controls Blue Water Webinars, you should see that playlist up on there. And then when you open the playlist, you should be able to see all of the episodes that we've recorded so far, plus additional bonus content. We've made some videos about other topics, usually a little bit shorter, a little more bite-sized in nature, but please be sure to go check those out. And again, let us know if you have any questions or anything we can help you with. So with that, Craig, I'll turn it over to you for the agenda.
Well, thanks, Jonathan. We'll start our webinar today with a short talk about water utility worker safety and something that's very important to me personally, and that is protecting your hearing. I surely wish that I'd taken better care of my hearing when I was younger, because I am now paying dearly for my mistakes. And we will present the latest results from our static meter research project next. And we are now into our 13th year of this study into how well different water metering technologies work at typical residences. The results to date have been remarkably different than what we had anticipated at the beginning, but that's exactly why we do the research. And following that, we're very happy to have Adam Frank, who is the Commercial and Industrial Product Manager for Neptune, as our special guest today. Adam will be talking primarily about Neptune's MACH 10 ultrasonic water meter line, and Adam will also be giving us an update on all the new developments at Neptune. But first, I'm going to ask Audrey to talk about protecting your hearing.
Well, while most of us have developed the habit of wearing our safety glasses whenever we're working, and some of us have developed the habit of wearing cut-resistant gloves or better whenever we're working, there is another habit that we should develop, and that's protecting your hearing. If the noise level where you're working is above 85 decibels, you should be wearing hearing protection to prevent gradual hearing loss. The CDC says that regular exposure to 110 decibels of noise for more than 1 minute risks permanent hearing loss. How much is 110 decibels? Well, that's the noise level from a chainsaw. As you can see, most of the items inside our home have a noise level of less than 85 decibels. There are many items that we regularly use at the job site, however, that require hearing protection, such as tractors, drills, power saws, chainsaws, pneumatic drills, and jackhammers. When you're selecting hearing protection, you first need to know the approximate noise level. Next, look for the noise reduction rating, or NRR, on your chosen hearing protection, which should be listed clearly on the packaging. Your hearing protection system, you need one that will reduce noise level. For example, a power saw has a noise level of 110 decibels. If you're using a power saw to cut pipe, you'll need something to lower the sound level by 25 decibels. The highest noise reduction rating is provided by moldable earplugs that are being worn correctly, and earmuffs offer the next highest level of protection. For extra protection, you can wear earmuffs over your moldable earplugs, which is what I do whenever I'm at the gun range or hunting. The lowest level of protection comes from semi-insert plugs, which are 2 earplugs that are held over the ends of the ear canal by a rigid headband. While those are both convenient and easy to use, they just may not be as effective. Nothing on the job is worth suffering permanent hearing loss or having a constant ringing in your ears, especially when it can be avoided with a little precaution. I'd like to ask Craig, our resident water meter historian, to please give us a brief overview of static water meters and why Johnson Controls felt it was necessary to conduct this field research project back in 2010.
All right, well, Audrey, you obviously know me very well and how I'm always glad to talk to anybody about history. The English scientist Michael Faraday developed the operating principle behind the electromagnetic water meter in 1832, and you can see an illustration of his early experiments in the image at the left. The first commercial electromagnetic water meter, however, did not appear until 1950. It was the German engineering professor, Dr. Oskar Rutten, who filed a patent for an ultrasonic meter in 1928, and you can see a copy of his original patent application on the right. The first commercial ultrasonic flow meters were made in the early 1970s. Both of these water meters now have been available commercially for over half a century, and these water meters were mostly used for inside settings until the latter part of the first decade of this century. This is because static water meters require a constant source of electrical power, and the available battery technology simply couldn't supply the necessary power for very long. Moreover, it was also very costly to build a computer that could process the flow sampling data needed for reasonable water meter accuracy. The development of the lithium-ion battery and other remarkable improvements in both electronics and computer processing allowed for the creation of 1-inch and smaller static water meters with an expected lifespan of 20 years at a price that the market would accept. When the first small electromagnetic water meter was released in 2009, both the meter manufacturer and their distributors advertised that utilities who purchase and install these electromagnetic water meters would see an increase in revenue because a static water meter is more accurate at very low flow rates than is either a displacement type or a multi-jet water meter. Residential static water meters are designed to accurately measure usage at flow rates as low as 1/33rd of a gallon per minute, or even better. In contrast, new displacement and multi-jet type water meters typically cannot accurately register usage at flow rates below 1/8 of a gallon per minute. Therefore, it just seemed logical to expect that a static water meter would register more usage at a typical residence than either a new displacement type or a multi-jet type water meter. Over time, this increase in accuracy should become even more pronounced as viscous effects and water quality issues limit the ability of displacement type meters to accurately register usage at low and very low flow rates. The residential end uses of water study that was published by the Water Research Foundation in 1993 seemed to support the claims from the manufacturers. The study, which was conducted at 5 water utilities across the United States, sought to understand how private residences used water. Demand recording devices were installed on residential water meters for several months, and the results showed that on average between 4.3% and 6.3% of the flow at a typical residence was below that for which both displacement type water meters and multi-jet water meters were designed to accurately measure, but that static water meters could measure. One day, my boss at the time and I were discussing the validity of the claims from the static water meter manufacturers, and he turned to me and said, "Go prove it." Following the scientific method that we all learned in school, I first drafted a purpose statement. First, I wanted to determine if a typical residence would experience a noticeable increase in registration at very low flow rates with a static meter versus a displacement type water meter. Second, I wanted to determine if a typical residence with a static water meter versus a displacement type water meter would experience a noticeable increase in registration over time because, unlike a displacement type water meter, static water meters are virtually unaffected by viscous effects or water quality issues. And third, I wanted to determine if water and sewer revenue generated through an increase in registration offsets the higher initial cost of the static water meters. The plan was for me to track the performance of the water meters in the experiment until either the water meters died or I died, and I surely hoped that the former would occur before the latter. Our procedure was to find utilities with meter boxes of sufficient size and depth to hold a tandem water meter setter that had an AMI system so that we could obtain hourly usage data from each water meter and that were willing to participate in a long-term study. I affirm that having hourly usage data from every water meter in this study has been a critical factor in our success. We were installing a water meter and AMI system project for Olathe Municipal Services in late 2010, and they graciously agreed to take part of the study. Glendale Water and Power next joined the study in June of 2012, and the Salisbury-Rowan utilities in North Carolina joined the study in September of 2012. We asked each of the three utilities to select the residences that would be used in the study, and we asked the utility to install the static water meter on the forward setter and to install the displacement type meter on the aft setter so that the flow entering the static meter would be undisturbed. We also tested the tandem setter arrangements at the Utah Water Research Laboratory to confirm that neither the tandem setter nor the position of the displacement type water meters and the static water meters would affect the accuracy of either water meter. And Audrey, since you live reasonably close to Glendale, may I ask you to please present the results to date from that city?
I'd be glad to do that for you, Craig. Glendale Water and Power is a Badger meter water meter customer, and they use a 3/4 inch meter as their standard residential water meter. In this experiment, we're using both a 3/4 inch Badger meter E-Series first generation water meter and a 3/4 inch Badger meter M35 nutating disc positive displacement meter. Both water meter types are read through an Itron water save source AMI system. Glendale is the 4th largest city in Los Angeles County, and the city is located 10 miles north of the city of Los Angeles. The city has a population of about 200,650, and Glendale is the home of DreamWorks Animation, the International House of Pancakes, Avery Dennison, and many other large corporations. There are 2 factors in Glendale that may affect the results of the study, however. Besides using a larger 3/4 inch residential water meter, Glendale has very hard water. The average water hardness is 12 grains per gallon or 205 ppm calcium carbonate, and the very hard water will eventually allow scale deposits to form on the walls of the measuring chamber inside those displacement type meters. These scale deposits will affect displacement type water meter accuracy at both low and intermediate flow rates. To date, the difference in registration between the ultrasonic water meters and the displacement type water meters is most noticeable in Glendale. Overall, the ultrasonic water meters have registered 30,787 more cubic feet, or 230.3 more K-gallons of water than have the displacement type water meters. This could be attributed to a combination of using the larger 3/4 inch water meter and to those scale deposits beginning to form after about the 6th year of service. There are 5 services included in the study in Glendale, which we readily acknowledge to be a very small data set. We've highlighted the data sets from the water meters at Downing, Zook, and Cedar Streets because the percent difference between the E-Series registered usage and the M35 registered usage exceeds 2%. Overall, the total percent difference between the E-Series registered usage and the M35 registered usage is 3.72%. And the overall monthly average percent difference between the E-Series registered usage and the M35 registered usage is 3.4%. Out of 635 monthly records to date, the M35 displacement type water meters have registered more usage than the corresponding E-Series ultrasonic meters, only 18 times. This is a bar graph of the data from the previous table. You can readily see the higher percent differences in usage between the ultrasonic and displacement type water meters at Downing, Zook, and Cedar Streets on this bar graph. And the next bar graph shows the total ultrasonic water meter usage less the displacement type water meter usage in cubic feet on a monthly basis. On average, the 3/4 inch ultrasonic water meters measured 242.4 cubic feet, or 1,813.3 gallons more than the 3/4 inch displacement type water meters. This bar graph shows the monthly percent differences between the E-Series ultrasonic water meter usage and the M35 displacement type water meter usage. Overall, the average monthly percent difference between the two water meter types is 3.4%. From December 2016 through April 2020, the monthly percent difference between the M35 recorded usage and the E-Series recorded usage was steadily increasing, except during the summer months. Between April 2020 and June 2021, however, it appeared that the monthly percent difference between the M35 recorded usage and the E-Series was steadily decreasing and reached record lows in July and August 2020 of 0.59% and 0.77%, respectively. The trend reversed itself after about June 2021. It is interesting to note that the average total percent difference between the M35 usage and the E-Series usage between December 2016 and April 2019 is 5.14%. But the average total percent difference between the M35 usage and the E-Series usage between May 2020 and February 2021 is slightly less than half of that at 2.4%. March 2021 is the lone exception. During that period, usage between May 2020 and February 2021 with a spike of 6.28% because of the high percent differences in usage between those two different meter types at both Downing and Zook Streets. This bar graph shows the overall monthly percent differences between the E-Series ultrasonic water meters and the M35 displacement type water meters. The decrease in the percent difference during the summertime can possibly be explained through the research that was conducted by McKenna L. Sumrack, Michael C. Johnson, and Stephen L. Barfus of the Utah Water Research Laboratory that was published as Comparing Low Flow Accuracy of Mechanical and Electronic Meters in the June 2016 issue of the Journal of the American Water Works Association. Their research proved that displacement type water meters are more accurate than static water meters at high flow rates. One area in which static water meters seem to provide greater benefit than displacement type water meters is in detecting leaks at a residence. There was a confirmed leak at the service on Cedar Street between October 2016 and September 2017. The data strongly indicates that the E-Series ultrasonic meter was both detecting and measuring the water loss from the leak more accurately than the M35 mutating disk positive displacement water meter. This scatter graph shows the approximate flow rates in gallons per minute for both the M35 displacement type water meter and the E-Series ultrasonic water meter during the hours of midnight, 3 a.m. and 5 a.m. for the months of January, February, and March 2017. This data further illustrates that the E-Series ultrasonic water meter is better able to register usage from a leak than that M35 displacement type water meter when there's a leak at a residence. Overall, the percent difference in registration between the ultrasonic meter and the displacement meter at Cedar Street during the hours of midnight 3 and 5 was 21.93% in January, 21.73% in February, and 33.31% in March of 2017. Again, we acknowledge this is a rather small sample size from which to draw conclusions. As both Jonathan and Craig will illustrate in just a few moments, it does appear that the difference in registration between an ultrasonic meter and a displacement type water meter appears to be greater with 3/4 inch meters than with 5/8 inch meters, and especially if there's a leak on the property. Overall, there's a 3.72% difference in usage between the two different meter types, and the monthly average percent difference is 3.4%. Lastly, there is a consistent decrease in the percent difference in registration between static water meters and displacement type water meters in those summer months. Finally, the percent difference in usage between the ultrasonic water meters and the displacement type water meters was below 3.5% for the first 4.5 years, except for 2 months. Starting in February of 2017, the percent difference in usage started increasing substantially and peaked at 8.86% in February of 2019. From May 2022 to the present, the average percent difference in usage between the two water meter types has decreased back to 6.15%. Excuse me. Jonathan, you live in an East Coast state. Would you please provide us a summary of our research project in Salisbury, North Carolina?
Absolutely, Audrey. Happy to do that. So like Glendale Water and Power, Salisbury-Rowan Utilities is also a Badger meter customer, but they use a 5/8 by 3/4 inch meter as their standard, as opposed to a full 3/4 inch meter like in Glendale. In Salisbury, we're using a 5/8 by 3/4 inch Badger meter, E-Series, first generation ultrasonic water meter, and a 5/8 by 3/4 Badger meter M25 nutating disc positive displacement meter, which have been arranged in series with one another, like Craig discussed earlier. Both water meter types are read through the Badger meter beacon AMA system. Salisbury is one of the oldest cities in North Carolina. It was founded in 1753, and the city contains 5 local historical districts and another 10 locations which appear on the National Register of Historic Districts. Salisbury is a very convenient place to live if you are a NASCAR fan, because the city is located a mere 25 miles north of Charlotte and less than 60 miles south of Winston-Salem. The current population is a shade under 36,000, and Salisbury-Rowan Utilities has very soft water to the tune of 30 parts per million of calcium carbonate, which means that water quality should have a negligible impact on the accuracy of the positive displacement meters. As Craig said earlier in the presentation, this is a prime example of exactly why we do research. The results that you're seeing in Salisbury, or that we are seeing in Salisbury, are the exact opposite of what Audrey just presented to you from Glendale. To date, the mechanical displacement type meters are consistently registering more usage than are the ultrasonic meters. Overall, the mechanical meters have registered slightly more than 60,000 gallons, or nearly 45,000 cubic feet, more water than have the ultrasonic meters. Put another way, the mechanical meters have registered exactly 2% more water than have the ultrasonic meters thus far in the study. There are 10 services in Salisbury, and you can see them here on this slide. We've highlighted the data set located at 1312 solely because there is no data from September 2021 to the present, and the data set at 1323 is highlighted because it is the only service out of the 10 in which the ultrasonic meter is registering more usage than the displacement type meter. Overall, the total percent difference between the E-Series registered usage and the M25 registered usage is -2%, and the overall monthly average between the ultrasonic usage and the PD registered usage is -1.6%. Again, negative percentages mean that the mechanical meter is registering more than the static meter. This is a bar graph of the data from the previous table. You can clearly see that the displacement type meters have consistently registered more usage than the ultrasonic meters in our study to date, with the obvious exception of service number 1323. However, the graph on the next slide indicates this may be changing. This graph shows the total ultrasonic meter usage less total displacement type meter usage in gallons on a monthly basis. Once again, a negative number means that the mechanical displacement type meter is registering more than the ultrasonic meter. And if you look at the data from an overall aggregate, mechanical displacement type meters have registered an average of 364 gallons, or roughly 49 cubic feet, more than the ultrasonic meters each month. However, you may notice that the story changes a bit after January 2022. And if you segment the data a little bit, the average monthly difference was minus 382 gallons from September 2012 until January 2022. But the average monthly difference from February through December of 2022 was a positive 180 gallons. Moreover, there were only 2 services in which the displacement type meters registered more usage than the ultrasonic meters during that time in December, through December of 2022. So you could say that there's been quite a swing in momentum over the last year or so. And needless to say, we're going to keep our eye on that to see if that new trend continues. This bar graph shows the monthly percent difference between the ultrasonic meter and the mechanical meters that we discussed a few slides ago. Overall, the average monthly percent difference between the 2 meter types is minus 2%. However, you'll recall from the previous slide that the ultrasonic meters have been registering more usage than displacement type meters since February of 2022. The reason that this chart shows strongly negative percentages during the last 3 months of 2022 is because of the extraordinary large percent differences at service number 1317. The percent differences at the service were minus 148% in October 22, minus 69% in November 22, and minus 127% in December 22. Thus, the data from service 1317 is skewing the overall results for the last 3 months of 2022. This bar graph shows the overall average monthly differences in gallons between the ultrasonic meters and the displacement type meters. And as I've mentioned a couple times now, there is a decrease in registration difference in the summer months. We saw the same thing in Glendale. Given the fact that displacement type meters have been consistently registering more usage than the ultrasonic meters from September of 2012 through December of 2021, quite honestly, we simply can't explain why the differences between the 2 meter types are noticeably decreasing when theoretically they should be increasing during the summer months. So as Audrey illustrated previously in her review and analysis of the data in Glendale, there is one area in which static meters seem to continually provide a greater benefit than displacement type meters, and that lies in detecting leaks at a residence. This was a leak that occurred at the service number 1327 on November 28th of 2017. And if you plot the hourly usage data from both the displacement type meter and the ultrasonic meter, it quickly becomes apparent that the ultrasonic water meter registers more usage than does the displacement type meter during the leak event. And you can see that you spot the leak because usage never drops to 0 at any point. And speaking of never dropping to 0, this was the exact same service just a couple months later in January of 2018, where again, the usage never dropped to 0 for multiple days. And I'd like to use this as an opportunity to point out one of the perks of having an AMI system installed and having that hourly service data usage data that's updated multiple times per day really makes it a lot easier to identify services that have leaks. And if you have a customer engagement portal, you can automatically notify the account holder that there may be a leak at their property as well. This is especially valuable service to those customers who are on a fixed income, and it also facilitates prompt resolution before any billing disputes make their way through the mail or to the checking accounts of those people who are paying. So if you don't already have an AMI system, or if you feel like this pig a little bit here who's just kind of floating in the water, probably sinking here. I don't think piggy banks are too watertight. If you need to implement a customer engagement portal, other water loss conservation measures, energy conservation measures, whatever it may be, please send us an email at bluewaterjci.com. We would love to sit down, learn about the challenges that you're facing, figure out how we can help you. If it's a lack of funds that's preventing you from making those necessary improvements, we have a number of different vehicles that we can look at and try and get that done for you sooner rather than later. So again, bluewaterjci.com. All right, so in conclusion, back to Salisbury here. The mechanical displacement type meters have consistently registered more usage than did the ultrasonic meters in Salisbury from September 12 through February of 21. After February 2021, however, the ultrasonic meters have begun to register slightly more usage than displacement type meters in most months. And the difference in registration between the two water meter types is relatively small, and the ultrasonic meters seem better at detecting leaks at a residence than do displacement type meters. We're excited to continue our study in Salisbury to see where that data leads us next. All right, well, now I'm going to hand things back to Craig. Craig, what can you tell us about what's going on in Olathe, Kansas?
Well, Jonathan, Olathe Municipal Services is a census customer, and they use the 5/8 by ½ inch SR2 water meter as their standard residential water meter. In this experiment, we are using both 5/8 inch census iPearl electromagnetic water meters and 5/8 by ½ inch SR2 oscillating piston water meters. Both water meter types are being read through a Census FlexNet AMI system. And when you drive through Olathe, everything seems new and modern. You would never know that the town was actually founded in 1857 and was a stop on the Oregon Trail, the California Trail, and the Santa Fe Trail. Olathe is located on the southwest side of the Kansas City metropolitan area, and it is the fourth largest city in Kansas with a population of about 143,000. The water in Olathe is hard with an average water hardness of 10 grains per gallon or 180 parts per million calcium carbonate. In the 12 plus years that we've been collecting and analyzing the hourly usage data at the 22 residential services in Olathe, the electromagnetic water meters have registered slightly more water than did the displacement type water meters. To date, the electromagnetic water meters have registered 11,909.5 cubic feet or 89,090 gallons more water than the displacement type water meters, which is only a 0.7% difference between the two water meter types. And this bar chart compares the percent differences in registration between the two different meter types at each of the 21 active services. A positive percent difference indicates that the electromagnetic water meter has registered more usage than the displacement type water meter at that service to date. Conversely, a negative percent difference indicates that the displacement type water meter has registered more usage than the electromagnetic water meter to date. You can see from this graph that 8 services have a positive percent difference and 13 services have a negative percent difference. More importantly, however, is the fact that 13 of the 21 active services have a percent difference that is within plus or minus 2%. And while overall the electromagnetic water meters may have registered more water than did the displacement type water meters, it is important to examine the usage from the two different water meter types each month. As this chart illustrates, the total difference in usage between the two meter types is insignificant when the data is analyzed on a monthly basis, and especially during the summer months. Subtracting the total monthly average usage for the displacement type water meters from the total monthly average usage for the electromagnetic water meters yields an average monthly difference of only 82 cubic feet or 614 gallons. To date, the displacement type water meters have registered more usage than the electromagnetic water meters 28% of the time. Now, I have to say last year was a very interesting year in this study because we set 3 new records. In May of 2022, the displacement type water meters registered a new high of 237.5 cubic feet of water more than did the electromagnetic water meters. But that record was broken just the following month when the displacement type water meters registered 257.7 cubic feet of water more than did the electromagnetic water meters. That record was broken for a third time in September of 2022 when the displacement type water meters registered 307.5 cubic feet of water more than did the electromagnetic water meters. The data does reveal that the electromagnetic water meters tend to register slightly more usage than do the displacement type water meters during the winter months of November through March. Conversely, registered usage during the summer months shows that the displacement type water meters often register more usage than do the electromagnetic water meters in those same months. And the above chart confirms that the total difference in usage between the electromagnetic and displacement type water meters is relatively minor when the data is analyzed on a monthly basis. This maximum percent difference between the total electromagnetic water meter registration and the total displacement type water meter registration occurred between December and February 2014, and once more in June of 2014, with the maximum value obtained during this period of only 3.58%. The month of February 2022 saw a recent high value of 3.35%, but the average monthly percent difference to date is only 0.77%. We did see another big change in 2022. For the first time ever, the monthly average of electromagnetic water usage, less the displacement type water meter usage to date, was negative for the month of July. The months of June, August, and September are very close to parity as well. After more than 12 years of collecting monthly data in Olathe, it does seem reasonable to conclude that the electromagnetic water meters are better than the displacement type water meters at accurately measuring usage during the winter months when there is only minimal irrigation and overall usage is less. In summary, the electromagnetic water meters have registered 2% or more usage than the corresponding displacement type water meters at just 4 out of the active 21 accounts. Conversely, the displacement type water meters have registered 2% or more usage than the corresponding electromagnetic water meters at 4 of the 21 active accounts. And there is less than a 2% difference in usage between the two different water meter types at the other 13 active accounts. There are so many people I need to thank for making this ongoing research project possible. Time prohibits me from reading everyone's name today, but I am so very grateful to everyone whose name is listed on this slide. And if you have any questions about the research project, if you would like to be added to the quarterly distribution list for the project updates, or if your utility would like to participate in this study, please send an email to us at bluewater@jci.com. I'm now going to ask Jonathan to introduce our special guest, Adam Frank, who is the product manager for commercial and industrial water meters for Neptune.
Yeah, thank you, Craig. So Adam, if you're out there, welcome to the webinar, and I'm going to turn things over to you here.
Thank you, Jonathan, Craig, and Audrey. It's great to be here. I appreciate the invitation to join you today and really to talk about ultrasonic metering. Impressive study you all have accomplished there over the last decade, and I think what I'm going to share today from Neptune is really going to just piggyback a lot of what you're seeing on the data that you've shared with us today. As you mentioned, I am with Neptune, a product manager for our commercial and industrial meters. That also includes our fire service line as well. I've been in product management in the technology industry for the better part of 20 years, everything from wireless to now metering. So it's been an exciting 2 years with Neptune and the CNI MACH 10 released a couple of years ago. Just in general, a little background on the timeline of Neptune's ultrasonic journey. We started a little after your study came along. Neptune spent some time in analyzing the market and the trends in metering, and really got into development of the ultrasonic and our own proprietary version of that around 2014 with the smaller sizes, the 5/8 through 1 inch. And then moving along to the intermediate 1.5 inch, 2 inch sizes a little later. And then as of the last couple of years, we released a 3 inch and through a 6 inch. And just a couple of years ago, the 8, 10, and 12 inch came along as well. And so that's my area of expertise with Neptune, is the CNI MACH 10. So I'm going to share today a little bit about those particular sizes and some of the data we've seen just from the last couple of years where customers have converted those to the Mach 10 over traditional mechanical meters they've used in the past. The commercial industrial Mach 10 is the C&I Mach 10, as we call it. It's really just a scaled up version of our residential and intermediate sizes, bigger pipe, so maybe a little more to the measuring element, so to speak, but ultimately it's the same technology under the hood that's operating these meters. Again, we offer a full lineup of bronze ultrasonic meters from 5/8 to 12 inch. It's going to be the widest range of sizes in bronze ultrasonic that you'll find on the market today. Those are all manufactured by Neptune in our headquarters in Alabama. So we're proud of that, and proud of the bronze that we use there to make a very durable meter. Again, those sizes are 3, 4, 6, 8, 10, and 12 in the C&I. And they come in a variety of lay lengths for compound and turbine. Specifically, the 3, 4, and 6 are available in both of those, where the 8, 10, and 12 are available in turbine lay lengths. But we really believe the C&I Mach 10 is the future, especially in large metering. It's an alternative replacement option for those existing compound turbines and even fire service meters that so many utilities are managing today in their infrastructure. Just a snapshot of the flow and sizing comparisons for the 3 through 12 inch here. Very comparable flow ranges to compound meters, which is one of the target conversions that we're looking to make out in the utility and municipalities out there. So really low flow, the extreme low flow capability for that leak detection that you've already pointed out in your studies. The same applies to the large meters as well. You can see the 3 inch all the way down to 1/2 gallon per minute, and the 12 inch is as high as 8,000 gallons per minute. So a fairly wide range of flow performance there. And the graphic here is really just kind of illustrating what the AWWA C715 outlines for electronic solid state meters, and what range expectations for flow they expect from these type meters. And then in the blue, you see what the Mach 10 actually achieves beyond those C715 specifications. So really proud of that flow range. And honestly, these are the specs. These are what you'll find on Neptune's product sheet. But in a perfect world, in good conditions, proper installations, you can honestly expect to see even lower flows detected in these meters when the conditions are suitable. So the unitized measuring element is a key benefit of the Mach 10 or UME. So we basically mirrored the concept from mechanical meters, where we had UMEs that provide easy maintenance and servicing of meters when they need to be maintained. The UME on the Mach 10 contains all the potted electronics, the measuring elements, transducers. It is the industry's only solid state UME currently, so we're pretty proud of that. It really makes or will make servicing these meters at the end of their useful life very simple. Just in a trial basis, this takes about 10 minutes to change out. We've had a few utilities do a kind of a trial run on some of these, and just basically just unbolt the UME, pop it in and out in all about 10 minutes. So here's a little data to kind of piggyback off some of your studies. This particular installation was a fire service compound meter, 8 inch in size, at a hospital. So it's a small sample data, as you point out, where this C&I Mach 10 has only been on the market a few years. So we're kind of tracking several accounts that have been converted already. So it is a small sample data, but it's impressive to say the least. What we're seeing in these 8 inch comparisons here is in blue there, you'll see the prior 8 inch compound meter and its performance over the last couple of years. But then in October of 2021, the Mach 10 was installed in its place. And then the green lines, as you can see, represent that consumption history for the Mach 10 year over year compared to the fire service compound meter. the Mach 10 was registering about 3% more than the fire service compound meter. Now that's impressive because of at least the low flow specifications on a fire service compound, which uses a 2-inch disc meter in its bypass, compared to the low flow expectations of a Mach 10. Regardless of those expectations, we see that the Mach 10 is tracking right along in consumption compared to that compound's bypass meter there. And the benefit that this utility now sees going forward at this particular installation is no maintenance. As you know, in a compound fire service meter, there is a ton of parts. There's 2 meters basically to service when that time comes along. But going forward, they have no moving parts inside this Mach 10, nothing to maintenance. So they're going to get that added benefit in addition to the same or better consumptions. This is another great example of where an 8-inch Mach 10 is really compared to positive displacement meters. This particular installation was at a business park, and it's the 8-inch Mach 10 was installed upstream of the business park, kind of serving as a master meter for comparison measurements. And what we see is the blue line there represents the Mach 10's consumption history over a period of a few months. Again, small sample size, but it shows a trend of the 8-inch Mach 10s essentially tracking right along with the cumulative sum of those 9 disc meters downstream. Those disc meters range anywhere from 3/4 inch to 2 inch in size. And so it's pretty impressive that an 8-inch meter is seeing as much or more water in some instances than these disc meters at each of these installations. So it's just an example from our standpoint of how technology is really improving the flow registration in large meters, able to track flows that were traditionally only available or capable of being tracked in a small disc meter. And one last story here, we have a customer in Columbus, Georgia, a fairly large utility providing water to not just their citizens, but neighboring communities as well. This particular installation was a compound meter in 6-inch size that they replaced with a 6-inch Mach 10. The city of Columbus has adopted the Mach 10 for all new construction as well in the 2-inch and up sizes. They've been pretty impressed with what they've seen on their usage of it. This particular site was an emergency clinic. However, it wasn't an emergency clinic initially. It was converted to one, which means that the infrastructure when it was built was not set up in a way to provide multiple sources of water coming into the facility. So that presented a challenge for the utility to maintenance and test the 6-inch compound meter. And so the Mach 10 really presented an opportunity for Columbus to solve this problem by installing it in place of the 6-inch compound. And for all intents and purposes, the compound meter was in good working order. It was simply the downtime to maintenance or test this meter at this critical infrastructure that they wanted to kind of have a solution for. So to solve this problem, the Mach 10 was installed, and as you can see here, around Q3 of 2021 was when the installation took place. And the Mach 10 is seeing as much or more water than the prior compound meter in its place. And so that's really solved yet another problem, not in just tracking water, but maintenance or testing downtime that so many mechanical meters are in need of to stay in good operating working order. So it's not just really about the benefits of the flow. There are other problems that ultrasonic meters are solving, as well as saving costs on the utility side, allowing them to allocate resources elsewhere. Instead of maintaining meters, they're dealing with customer complaints or other areas of the utility that need addressing. So that hopefully was insightful for everyone. I think it backs up what Johnson Controls has shown today with regard to ultrasonic metering. I think it's not just the future. I think it's here. I think a lot of people have already started adopting these new meters, and they are the future. And really, the migration has already taken place to ultrasonic metering, in Neptune's opinion.
Yeah,
Well,
absolutely.
Adam,
Yep, go ahead.
Adam, I have a question for you if you've got a
Sure.
minute.
Absolutely.
And this is a question that I get quite frequently, and I know we get it on the AWWA Metering Standards Committee as well, and on the M6 Manual Committee, and that is about strainers. When you have an ultrasonic meter or an electromagnetic meter, what are your thoughts about strainers? Are they necessary or not? And then, if the existing strainer, this is a two-part question. If the
Sure.
existing strainer, if there is an existing strainer, should it be positioned upstream or downstream of the meter if you're using a Neptune Mach 10?
Sure. Well, our testing has shown that the strainer is really negligible to the performance when it's mounted up against with the meter. That said, with no moving parts, if I'm asked or if we're asked, we typically don't recommend a strainer because it simply adds cost to the investment there, as well as can be a space constraint. So strainers aren't necessary. A lot of people still prefer or require strainers, and that's acceptable as well. We'll typically, because there's less concern about protecting the insides of the meter and certain parts, we'll recommend putting that immediately downstream. However, again, our testing has shown upstream or downstream at the inlet or the outlet is acceptable.
Okay. All right. Well, thank you.
Absolutely.
And on that note, if there are any other questions out there in the audience, feel free to submit those in the Q&A box. Happy to have Adam answer any questions that you have. All right. Well, with that, I'm gonna take back over here. All right. So, Audrey, do you wanna bring us home and just show us or tell us about the next webinars?
I would be glad to do that, Jonathan. Please join us for the next Johnson Controls Blue Water webinar on Wednesday, March 15th at 11 a.m. Eastern Time, 8 a.m. Pacific Time. We have a very fun webinar prepared for you next month about one of our favorite topics, lessons we have learned through the 2 decades that we've been developing, installing, and commissioning water loss optimization projects and AMI system projects. We'll provide you with actual examples of what can happen if you choose to ignore one or more of the best practices that we'll be presenting. This is a webinar that you cannot afford to miss. Gary Lee and Dave Rubin from Aclara will be our special guests, and they'll be giving us an update on the Aclara Star AMI system for water utilities. You can register for this free webinar by using the link that you see on the slide, capturing the QR code on the slide with your smartphone, or just send us an email at bluewater@jci.com and we'll just email the registration link right to you. A very special thank you to Adam Frank from Neptune. We want to remind you to please invite your friends and colleagues to attend Blue Water webinars, and please submit topics you want us to cover in future webinars. We really want to know what's important to you and your utility. You can contact us at bluewater@jci.com. So thanks for attending the Johnson Controls Blue Water webinar today, and we look forward to seeing you again on March 15th.